Quantum spinning bucket experiments. Newton's spinning bucket experiment efforts, like those of the pre-Socratic philosophers Parmenides and Heraclitus, no, they weren't partners, examined the nature of the volume, that is space. We would say space-time rather than just space, yet that may be a convention too, as time seems like a secondary rather than a primary quality of space. Time cannot appear without mass, energy, or matter to act upon, with differential values in relation to the location and characteristics of mass. One might wonder about the nature of the volume that contains a universe, or universes, or any possible configuration of universes, including a multiverse. Typically, physicists tend to describe the configuration of matter or antimatter and energy existentially and phenomenally as if it only existed rather than volume of space. It seems rather plain that a volume of space, truly empty void that hosts the universe, doesn't figure in the calculations of modern cosmology. Instead, various fields arising from an initial solitary unified field, when indubitably made of energy, a singular sort and condition of energy, pervade the expanse of the universe. The universe exists only as far as the fields expanding from the initial singular unified field at time equals zero have traveled. There are many interesting points about the four basic fields of the universe that one might consider. Gravity is said to have split off first, followed by the strong force. The strong force split and released the electroweak force, dividing into the weak force and electromagnetism as the Higgs fields arose. Apparently, each of these fields must equally pervade the entire universe, yet they may be induced local field phenomena that appear in the presence of entangled mass and energy. What is called space-time is different than the volume of void that hosts it. Space-time, mass, and energy is regarded as having four dimensions, yet no one knows what a dimension is or if it is made of anything. The field energy filling the entire universe or making the entire universe is thicker and thinner in various regions as far as mass, dark matter, energy, and dark energy go. Overall, one might expect that it logically should be generally equally distributed in all directions from the time equals zero expansion, though not exactly. Because energy is changed, it could cancel out through various means such as matter and antimatter contacts and spin anisotropy and generate uneven distributions. It is also the case that energy becoming entangled in the Higgs field generates the appearance of mass, and mass is a secondary characteristic of the fields that comprise the universe rather than primary. It is possible that there is a difference between primary and secondary fields and field phenomena. The speed of light is the fastest possible speed for matter or energy entangled in the Higgs field, yet the primary fields are not subject to the laws of general relativity, perhaps unlike possible secondary fields like electromagnetism. Gravity itself may be just a field-generated phenomena and a secondary phenomena without a graviton to transfer its power. Some wonder much about the spooky action at a distance of quantum entanglement. Mass in one location may quantum entangle with mass at a distance. Perhaps the concatenated quantum entanglement of mass with other mass at a distance faster than light creates a secondary effect of mass attracting other mass at light speed. Light speed would be slow in comparison to the faster-than-light status of primary fields hosting the matter and sublight speed energy of the universe. Gravity waves would be generated by mass quantum entanglement comparable to the way that waves may be generated in the water of a swimming pool by a mechanical push at one end of the pool. Gravity waves in three normal human universe dimensions of experience reflect mass quantum entanglement occurring in the primary fields faster than light and lacking the spatial distance values inherent in the subluminal universe. Still, it is interesting to consider a bucket whirled at the end of a rope half full of water that is in empty space. There is a problem with the definition of empty space affecting the outcome of the experiment. If the bucket was spun in this universe, it would be acted on by the fields pervading this universe. If it was truly in the void that hosts the universe, and the universe did not exist, just the bucket and the experimenter, then the experiment in the bucket would be quite anomalous. There would be microgravity in this universe, while in the true void not even the experimenter or bucket could exist, since they are generated from quantum field effects of entanglement in the Higgs field. Some experimenters and theorists have conjectured about extra dimensions, maybe smaller ones that might exist in the universe in order to explain the structure of matter. Besides the obvious problems that appear when considering time as a dimension with factors of general relativity at the quantum scale, there is the problem of the nature or the void that hosts the universe. How many dimensions does it have, and could a universe appearing within it have more dimensions than the pure space void itself? Some physicists have said that a pure void does not exist and that only matter and prime energy exist, even if it is stretched very thin. Plainly, though, fields are primary and exist, although in what true form is to a degree still unknown. Fields exist and dimensions exist, at least within the space-time of the universe, where matter and energy arise in the Higgs field. Maybe those fields don't have the same dimensions as the contingent universe we live in, entangled as mass in the Higgs field, because they are not like this universe spatially. There is no distance comparable to the scales of this universe. Light speed is not a meaningful speed in fields without distances based on mass relations, a contingent phenomena. The fields is separate from the one singular field may be stacked together like layers in a computer chip and convey information in a different way, for a trivial example, horizontally and vertically rather than in a simple linear progression along a line. Nonlinear time passages based on a stacked layered field information would perhaps be different than that of inertially driven mass with relativistic time, such as occurs with special relativity combined with general relativity. I wonder, though, about the basic question of, can this universe have more dimensions than that of the true void? And I think the answer is no. If a true logical void has just 3 dimensions and one of time, then it probably wouldn't be possible to construct a 23-dimension or 230-dimension material universe within it. Mathematicians obviously can construct multidimensional models simply changing a number value, a variable. That sort of multiverse might have no correspondence to a real value in the world. Universe. Aristotle believed that words have a necessary relation to real objects and that its logic would therefore bring true results when formulating logical equations about the real world. Subsequent logicians discovered that words and material objects haven't a necessary relationship at all. That circumstance probably exists between mathematical models of quantum cosmology and actual quantum cosmology. It is a great tool that, applied probabilistically for making judgments, provides valuable insight, yet fails the kind of rigorous logic that Aristotle sought when inventing classical logic, although some dispute that he invented classical logic. A logical volume of absolute space would seem to have 3 spatial dimensions. A physicist friend of Einstein's, Paul Ehrenfest, said that human life couldn't exist in the universe with more than 3 dimensions and one of time. That judgment was made concerning the structure of quantum particles, yet if one considers a true void, primary empty space without fields with more than 3 spatial dimensions, perhaps 6 or more, it becomes increasingly difficult to imagine any sort of coherent universe structure existing within it. Could dimensions, rather than being fields of some unknown nature that exist for a true void, be better compared to vector directions? Within a 3-dimensional unbounded true void, there might be a veritable Cantorian infinite number of vector dimensions radiating out of some central point for simplicity in visualizing the structure, or existing in an infinite number of other ways with the straight spaghetti strands of some thicker or thinner dimensions than others. So while the universe built from 3 strands of spaghetti-like dimensions added together, selected to build a universe in, there could be thinner, smaller spaghetti strand dimensions mixed with it at the quantum level to support loop quanta, or something like mini spaghetti strings. Who can say for sure? The quantum chef of spaghetti sauce may explain the secret recipe someday.